Hello and welcome to our lesson on like terms and exponents. First of all, let's talk about what is a like term. Like terms are terms, it could be a number, a variable, an exponent mix, in which the variable and the exponent are exactly the same, and that's the important part right there. So when we compare 4x cubed and 6x cubed, they're considered like terms because both have x's. So you've got your x there and your x there. And both are to the third power. Notice how your exponents match exactly. So those would be considered like terms. Let's take a look and see. Are these like or unlike terms? First of all, make sure that the actual variables are exactly the same. These are both x's, so far so good. And then here we have to look at the exponents. They're both to the fifth power, so these would be like terms. Now look at the second one. Look at the variable again first. You've got a y and you've got a y. So far so good. In order to be like terms though, remember you have to make sure that your exponents are exactly the same. They are both to the fifth power, so you again have like terms. Take a look at these. If we have z as both the variables, that looks good. Look at your exponents. What do you notice there? You've got one is to the fourth power and the other one is to the fifth power. They can't be like terms because the exponents are not exactly the same. So these are not like terms. Now take a look over here. Do the variables match? No, right there. You don't have to go any further. It doesn't matter what the exponents are telling you. If the variables don't match, these are not like terms. Notice on all these, I didn't care at all what was going on with the coefficients. It doesn't matter what they look like. It's all about your variable and your exponent. Now, what happens when you have like terms and it's telling you in the problem to add or subtract them? Both the variable and the exponent must be exactly the same. Again, here's your variable. And the little tiny number up there is your exponent. Only add or subtract the coefficient and do not change the variable or the exponent. That means that this number 3 here on my example is your coefficient. When we actually do our adding and subtracting, this number is the only thing that's going to change. You're going to keep writing the exact same variable and exponent on every problem. So take a look. First thing, are they like or unlike terms? You've got a variable x and another variable x. Looks good so far. Your exponents are both 6's. That means they're like terms, so you can actually add them. Now what you're going to add is only the 4 and the 1.2. So 4 plus 1.2, this is going to equal 5.2. And don't change your variable or your exponent. They stay exactly the same. Let's do the same thing here. Are the variables exactly the same? Yes, they're both y's. Are the exponents exactly the same? Yes, they're both 7's. That means that you can go ahead and this time subtract 1/4 minus 4. So if you are taking 1/4 and you are subtracting 4, you're going to end up with a negative number. And it's going to be negative 3 and 3/4. And then your variable and your exponent are still exactly the same. Don't change them. Again, if we are adding them, take a look. Are the variables exactly the same? Yes, so far so good. Are the exponents exactly the same? Yes, that means we have like terms, so we can go ahead and do what it tells us to do, which is take negative 6 and add 20 to it. So you're going to have a negative 6 plus 20, which is going to give you a positive number. That's going to give you 14. Your variable doesn't change. Your exponent stays exactly the same. This is going to be your final answer right here. Take a look at the next one. Are the variables exactly the same? Yes. Are the exponents exactly the same? Yes. That means that you have like terms. So take a look at your coefficients and do what it's asking you to do, which is subtract. So you're going to have 51 and you're going to take away 33. And if you want to go old school subtraction, 11 minus 3 is 8, and 4 minus 3 is 1. So that means that your final answer is going to have a coefficient of 18 and recopy the exact same variable and the exact same exponent. Let's do a couple of practice problems, and I would highly suggest that at this point you pause, try to do them by yourself, and then we'll go over them together. Now, if you're going to do like terms, first thing you do, remember, is check your variables. They're both q's. We look good. Let's check the exponents. They are not the same. One has a 7 and one has a 77. They're not like terms, so this right here is just going to be your final answer. You can rewrite it if you want. You're still going to have 4q minus 6q to the 77th. You can't do anything with that because they're not like terms. Go to the next one. You've got a variable x, looks good. Now your exponents, ta-da, they match. They're both to the 9th power, so you can actually add it. So you can take 3.5 and add 4 to it, which is going to give you 7.5. And then since the variables and the exponents are exactly the same, you're just going to rewrite them. So it's x to the 9th. The last one. Are the variables the same? Yes. Are the exponents the same? Yes. So we can go ahead and take our coefficients, and this time they want us to subtract them. If you have 1/2 and you take away 1/2, you've got nothing. So you have 0, y to the 4th, which just means you have nothing. So that answer is just going to be 0. Now for a quick review, having like terms means that both the variable and the exponent are exactly the same. The coefficient does not have to be the same. When you are adding or subtracting like terms, only add or subtract the coefficient. We are only looking at adding or subtracting the coefficient. Do not change the variable or the exponent. Remember how we kept rewriting the same thing? If you do not have like terms, you cannot add or subtract anything. You just leave it alone. And that's it for our lesson on like terms and exponents.